So, Google Hangout 1. Man, that second exam was a little bit more tough than I thought it was
Right,
going to be.
wasn't it? I thought it was a lot harder than what I thought it was going to be.
I know. On that multiple choice, I don't know if there was something wrong with the key or what, but I did terrible on it.
What'd you get on it?
A 50. But the thing is there's no way I could have got a 50 because all of those questions, I worked it, found the answer, and then plugged the answer back to the equation, and I got the right answer. So I'm super confused on how that happened.
Yeah, I mean, I think I got a 74 or something like that.
Yeah.
And I thought I did a lot better too. 74,
So,
something like that.
okay,
Yeah.
so
Go ahead and get started.
so
Just do lead here.
okay. So the sine of 4 pi thirds.
That's the one we just did. Radical 3 over 2.
Oh yeah, I was just saying that again. Okay. So then the sine of 7 pi. And so pi is 180 degrees. So you'd go once to 180, then twice would be back to 360. Then 3 times would be to 180. 4, 5, 6, 7. So on the 7th, you'd land at pi, or 180 degrees of 7 pi would be 0.
Oh, so on the second one?
Yeah, on the second one.
Okay, hold on.
Because 7.
So it's just saying 7 full circles?
Because pi is half a circle, and then 2 pi is a full circle.
Okay, so it goes, yeah. So the sine, is it sine or cosine?
It's sine.
Oh, sine of it. So it's
So if you 2 pi would be 6 pi would be 3 total rounds because 2 pi is one whole round. 3, and then to hit that 7 pi, you'd just go 1 half time around. So you'd be at -1, 0.
So the sine would be 0, right?
Yeah, the sign would be 0.
Okay.
Hey guys.
Oh, we got
Hey, what's
Peter.
up?
Sorry about that. I was at the dentist and it took a lot longer than I'd hoped.
Yeah, you're
No,
good.
you're good, bro.
Yeah, this crap open.
I'm pulling it up right meow.
All right.
Okay, sounds good.
I was so excited when I heard trigonometry. I don't know if that's I should still be excited or not, but I was.
It's actually, I finished all 4 assignments in an hour yesterday, so it's pretty good.
Really? Wow. Okay, that's good because my girlfriend's parents flew into town this weekend, this week. Sorry, they got in last night. Oh.
Yes. So I'm not completely done with it, but I got through. So I got 2 of them completely done, and then both of them halfway done, and it took me an hour.
Gotcha.
So
Hey, just a heads up, you guys, whenever next time we have an exam, make sure you click on the instructions. Otherwise, the multiple choice will not show up.
Oh, yeah.
Oh, there you go.
Yeah, I didn't know that, so I thought I was done with the exam Friday morning when I finished it. And,
Yeah, they do that on purpose.
Yeah, well, I figured it was the same for the rest of them, so, I guess that was my fault for assuming.
So did she open it back up for you?
Yeah, she said she'd open it back up for me for a couple of days so I could finish it. Dude, I had like a heart attack because I was like, no, I got like a 96 on the written. I busted my buckets for this. I was going to say,
Yeah.
I had like 8 other things I wanted to say there. I'm really trying not to swear. It's a big problem for me, apparently.
Is it Valentine's Day?
All day.
Oh, hey.
Yeah. Yeah, I work at UPS, so it was a nightmare this morning. A logistical nightmare.
Told you about my plan. All right, so we are working on these.
All right.
The first one we got do you remember the unit circle at all? I didn't.
Nope.
Okay, so
The what?
the best way to do it is to go to Google Images.
Okay.
And just type in unit circle.
Unit circle.
And there should be a circle with a bunch of freaking weird numbers.
I see it.
And then in the top right-hand corner or somewhere on there, it should be like cosine and sine.
Yeah.
Okay, so that's something we got to apparently memorize.
Are you serious?
Apparently. Not like in the next
So yeah, you're
day.
gonna have to memorize it. You're gonna have to be able to fill one of those out by yourself. But the thing is there's a strategy to it, and it'll all make sense once you study it out, and once they explain to you how to fill it out, it'll make complete sense.
Okay.
Yes.
And is that in that video that she
Yeah,
put
so
on
it's in the PowerPoint, and then if you just look it up on YouTube, like how to memorize the unit circle, there's like a strategy to it. So
how
All right.
to
So,
memorize good
7
old bull
pi
crap.
over 2.
so
So, like, this is the question I have. There's a 7 pi over 6, 7 pi over 4. I don't see a 7 pi divided by 2.
I don't either.
exactly. So that's why you have to convert it to radians. So you take 7 pi over 2, and then you want to get that into radians. So you times 7 pi over 2 by 180 over pi.
Oh, okay.
When you times that, so 7 times 180 is 1260. You divide that by 2, so then you get that in degrees, and so that's 630 degrees.
Can you rewind for a second? I dropped out of the call. So you said we got to convert it to radians, and that's where I missed.
Yeah, so in degrees. So if you times 7 by 180, you get 1260 because it's 180 over pi.
Okay.
That by 2 because it's 7 pi over 2. You come out with 630, which is the degrees. So you look at the unit circle and you go around 360. Once you go around 360, you're still left with 270 degrees.
Which is
So then
pi
you go to
over 2.
Over 2.
3 pi over 2. Oops, I went the wrong way. So I guess you go counterclockwise then.
Yeah, you go counterclockwise. And
Okay.
so that's 3 pi over 2. And then if you look below that, you see like a coordinate point or like the parentheses.
Yep. 0, negative 1.
Yeah, and so that right there is how you figure out the sine and the cosine. So the first number in the parentheses is your cosine, and the second is your sine. So the sine of 7 pi over 2 is going to be -1.
Okay.
So the whole thing about trigonometry is memorizing the unit circle, and once you memorize the unit circle, everything else just kind of comes. You just have to be able to read the unit circle.
Okay.
So
That's awesome. to me.
Perfect.
yep. So now on -9 pi, so now you have to go, now you go clockwise. And so a whole circle is 2 pi, and half of it is just pi. So if you go -9, so if you go around 4 times, that's going to be -8 pi. And then to go around half a pi or 1 pi more, you'd be left at pi or 180 degrees. Does that make sense?
Nope. One more
Okay,
time.
so the whole circle together is 2 pi.
Okay.
The circle is just pi. Like, if you look at the unit
Yeah,
circle,
I
you
see it.
you
Of
see
the
how
horizontal line, you got 0 on one side,
Yeah.
pi on the other.
and so 180 degrees is just pi, and then the full 360 is 2 pi.
Okay.
Okay, so if you look at the question and it's -9 pi, instead of going counterclockwise like we usually do, we're going to go clockwise because it's negative. Okay, and so if you go around, let's say 2 pi, if you look at the -9, you can make it around 4 times, right, to make it -8 pi, because each time around would be 2 pi.
Right.
And then if you want to get 9 pi, you just go around 1 pi, not 2 pi. So then you
So
just
it's
go
like
half
4.5.
a circle. So it'd just be half a circle, yeah. And so you'd be left at pi are 180 degrees. Does that make sense?
So wait, so then how do you write the answer for that though? Because I understand how you got the negative 9 pi. It comes out to being,
Okay.
you go
And so then-
clockwise 4 times and 4.5 times.
So now we got to the part where it's cosine. So it's the cosine of that. So then you look at the parentheses, and in the parentheses, the first number is cosine and the second number is sine.
So it's the first number.
Does that make sense?
So cosine of negative 9 pi, that'd be negative 1 comma 0.
No, just -1.
Because
-1?
cosine, because the cosine is -1 and sine is 0.
Oh, okay, gotcha.
So then, like, if we look at pi over 3, that's in the first quadrant because if you, here, let me
Yeah.
screen share this. It might be
Oh,
easier.
okay.
Here. Can you guys see my cursor?
Yeah, I'm looking at the exact same. Yep.
Okay, so this is the first quadrant. This is the second quadrant. This is the third quadrant, and this is the fourth quadrant. Yeah.
Okay. Yeah.
So if you look in the first quadrant, there's pi over 3 right here.
Okay.
For the cosine of pi over 3, which would make the cosine 1/2. Because cosine is the first number in the parentheses.
Okay.
Yeah.
So for the next one, we've got 7 pi over 4. Now, if we go look at our handy dandy chart, we have one of those that's in the fourth quadrant.
Yep.
So
And then
we
it's
wanna
asking
know
for the cosine.
cosine of that. So that would be square root of 2 over 2, right?
Correct.
Okay.
That is how you do it.
Awesome.
Do you want to do the next one, Austin?
Which one? 7 pi 4.
-5 pi over 4.
So that one, I'm assuming you can't just do the 5 pi over 4. You're going backwards. So is that one where you just multiply 5 by 180 divided by 4 and then find the degrees and change it?
I mean, that's probably going to be the easiest because there's a 5 pi over 4 on the unit circle.
That makes 225. It makes it the same thing.
You just go to the coterminal angle because it's going to be negative.
The
And so
coterminal angle.
Yeah, can you explain that real quick for those of us that don't speak math?
Literally,
yeah, so
dude,
you see how
I felt like
you know how
an idiot when you said that.
Hey, it's okay. One of us has to be smart and the rest of us can be dumb.
so you see where my mouse is starting right here,
Yeah.
the cursor. You know how we usually go this way?
Yeah.
Okay. Well, here's 5 pi over 4 right here, right?
Right. Right.
Are you seeing? Okay.
Yep.
So since it's negative, we're not going to be going this way. So if you look at it, 5 pi over 4 is going to be 225 degrees, right?
So we just. Oh, sorry. Go ahead.
So you're trying to do negative 225? Is that it?
Yeah. So then you'd go from here and you'd go down or around 225 instead of that way.
So that makes it the 135.
So you'd go 360 minus 225.
Which is 135. So it gets us 3 pi over 4, which in turn gives us a cosine or sine. Sine.
Brian,
So
you there?
radical 2 over 2.
I think Brendan dropped. I think now we're in trouble.
You can drop, otherwise we all would be dropped.
Oh. Yeah, I got nothing.
But do you understand that, what he's saying?
Yeah, so you just flip it over and go all the way around.
Yeah, so when it's negative and you do all of that, you still have a negative, so you have to turn it into a positive. Or, I mean, go backwards that many degrees. Or you can take that from 360 and then go forwards. Such a genius. Let's just keep going on. 19. So do you know the equation then to find these? So like for 19 pi over 6?
The equation?
Yeah. You just times 19 by 180 and then divide it by 6.
Gotcha.
It's
I
negative
remember
5
talking
pi
about
over
that
4.
one.
Yeah, you just times 5 by 180 divided by 4. So in this case, 19 times 180, divide that
It's a
by
big
6,
number.
you get 570. So then 570 has one full circle, so you can take away 360.
Did you guys drop me? You guys miss me?
210. We did
Okay.
miss you. So then 210 degrees right there. Was this sine or cosine?
Yeah, we hear you.
Okay, perfect.
Cosine.
What's on that last one?
So then it would
That'd
be
be negative
2
square
over
root of 3 over 2.
negative square root of 3 over 2.
Perfect.
We did one without you, Brendan, because we felt really smart. So we did the 19.
Got dropped off. The one before that.
We did 19 pi over 6.
And what did you get for the one before that?
Radical 2 over 2.
Yeah, that one.
Diagonal 2. Okay, yeah. And then the last one, you guys just converted it to degrees.
Yeah, we just did 19 times 180 divided by 6. It was like a big freaking number, 535 or something. Subtract 360, got the whatever.
So your answer was negative square root of 3 over 2.
Yep.
Yes.
Okay, perfect. Yep, that's what I got. So moving on. So to find the sine. Well, isn't this the same question?
That says the fundamental theorem of trigonometry is an important identity. So find sine pi over 3.
So the sine of pi over 3 would just be
Radical 3 over 2.
2, yeah. And then the cosine would be 1/2.
Yep.
You square. So if you square each thing,
You're
it
going to
would
get
be
1/4 and then 3/4.
yeah, and then find the sum that's going to be just 1. And then what did you find? Do you think this is always true?
So
Yeah,
I
it
think
will be.
what is always true?
Like, so we found that it equals 1, and so she's asking, do you think that it'll always
the
equal 1?
sum of them.
Yeah.
So then pi 4. Okay. So they're supposed to do the same for pi over 4 and pi over 6.
Yeah.
Yep, that's going to be the same.
Every time.
And that's going to be the same. Those two are the same.
Yeah. So what did you find? Do you think this is always true? Yes. Do the same process for pi over 4 and pi over 6.
Yeah,
So
those are
pi
the
over,
same.
yeah, it's going to be the same because it's going to be square root of 2, 1/2 plus 1/2. And then pi over 6 is going to be 3/4 plus 1/4. Yeah, it's always going to be the same.
Wait, what?
So if you look at the parentheses and
Okay.
square both of them, so 1/2 squared is going to be 1/4, right?
You're trying to find the sum of sine and cosine per each thing after you've squared them.
The sum and sine?
The sum of sine and cosine.
Okay.
Then you're trying to get them to equal 1. So when you have, like in pi over 3, you see the pi over 3, it's 1/2 and then radical 3 over 2.
On the little chart thing?
The pie chart, yeah.
Yeah.
So you have 1/2 and radical 3 over 2. If you square those, what do you get?
1/4 and then 3 over 4.
What happens when you add
what
those
is that?
two together?
It's 1. Okay.
So that's the theorem, is that out of all those angles that are on there, right? If you square all of them, adding them together, it's going to equal 1.
Okay. So then for pi of 4, square that. That's 2 over 4. 2 over 4 adds the 1. Pi over 6.
Yep.
3 over 4 and 1 over 4. Okay. Okay.
Yes. So what did we find? We found that it always adds to 1. And why
Yep.
do you think it works that way? I think it works that way
Because magic.
Because math is math.
Well, I said magic, but yeah, I mean math works too.
Well, it's the same thing.
Because yes.
Because yes.
I mean that's
So number 3,
technically an answer, right?
So number 3 I read. I don't really see a question.
Man, we're moving through this. Maybe we'll
I
get done
know.
before an hour today.
No,
Yeah,
literally
there's
there's no
no
question in number
for
3.
3.
It literally is just information.
Don't complain. We're basically done. We just have to talk about it, I guess. I don't know.
What is the formula for the motion of a spring?
So, PowerPoint, one thing we hope that you noticed was that if you use the Pythagorean theorem every time because the unit circus, that's pretty straightforward. Do you guys have any questions about the number 3?
No, it was just information.
Yeah. So I was actually looking at the key, and we did one of them wrong. The sine of negative pi over 4.
There was no negative pi over 4.
Or negative 5 pi over 4, sorry.
What was it?
What did we say the answer was?
Hold up.
Oh, we had that right. My bad. No, we did it right.
Yeah.
We did it. Yeah, we're good.
Should be
Good.
we're good?
Yeah, I just saw that she had it written down a different way, but then she converted it back to how she was supposed to have it, so we're good.
So does anyone I remember kind of what is the formula for the motion of a spring?
The what?
Number 4.
The spring? I'm opening up the book right now.
Okay. Because I don't really look at the book unless I have to.
Yeah. So yeah, I think the biggest thing is just a matter of memorizing how to fill out the unit circle. Yeah, and once you get it filled out, it'll be fine.
Yeah, that's the hard part.
What page are we supposed to be on in the book?
Yeah. Lesson 2. I don't know. There's no page number.
Sweet. Here, I'll just type in spring formula.
I don't know what that even means.
So we're going to start getting lots of word problems, and it's going to be like if I take a spring and I stretch it like if the amplitude of the spring is like 4, and if I move it back to resting motion, what is the amount of force that was added onto the spring? Like, it's just a whole bunch of stupid stuff that's really hard. So the spring formula is oh wow, that sucks.
What is it?
Is it
Here,
bad?
I'm not gonna make you guys open up the book. I'll just share my screen. Look at this. That's our equation right there.
VO over sine something something something. All right. Well, I mean,
Okay.
I think I'm
Initial
about to drop.
velocity, location. What's the bottom variable underneath the velocity? I can't see your cursors in the way.
W.
What the heck is W supposed to be?
I think it's weight.
So you have the velocity over weight, sine of the weight times time. Is that what T stands for?
I'm gonna assume this is important and recommend
Oh, it's right here.
write this down.
What page are you on? Page 358.
Location at time t. It's page 358.
What's the last half of it, real quick? I got the X cosine. I'm just trying to write it down. It helps me remember.
Oh, Peter, I'll write down 358 just in case you want to read about it.
Okay. Yeah, I got the page number written down here. Bless you. Bless you.
Yeah, so it's V subscript 0 over W sine WT plus X subscript 0 cosine WT.
BT, that was the. There we go.
Okay, so what was the purpose of her having us do this?
I don't know, dude. I can't even read good.
Discuss the formula for the motion of a spring and go through the practice problem. Okay.
Practice problem, I'm assuming.
So what are we doing? Like, so where's the practice problem at? Oh, there it is. Okay, so
Where do you
guys,
see
are
it?
you on example 8 on page 359?
Oh, it's in the book.
Yeah.
Okay.
And so it just gives us the numbers and we just have to plug it into our calculator.
I wish they'd let us download the book as a PDF.
That would be real nice.
Couldn't
Couldn't do that, and you print off pages and legally sell
Hey,
it for $12.
You can download it as a PDF.
Oh, you can?
Oh, so go to the bottom and it has like a little tab that says download. So it says like send to binder, reflect in e-portfolio, print, or download. I'm assuming that means download the book.
Let's try it.
I mean, I did spend $65 to be able to use this book.
My tuition was so expensive for this class.
Yeah,
Was it
dude,
really?
it's like $800.
Dude, I don't know why. Mine was like 900. 970.
For the
So
class?
where'd you download it? At the bottom? Download?
Yeah.
Okay. Hopefully it works. That'd be really nice.
That doesn't.
Nope, that's an HTML. All right, I've got an idea.
That's not it.
Well, if you just look at it.
Hey, I got it. Okay.
How'd you do it?
Okay, so go to print it.
I don't know if I want to print it.
Right, don't actually print it.
I know, it's just.
Never mind, it didn't work.
Oh.
That makes me sad.
Anyway, do we want to work on that problem, or do we just want to work on it on our own?
So, I mean, I think as long as we just talk through it, I think it'd be fine, and then we can just work out on our own. But it looks like they just give us the constants, and you just have to plug it into the equation.
Okay. Hopefully they do that all the time.
So, is that it?
I guess so.
Okay. Well, should we plan on Thursday at 12 then?
Sounds like a plan to me.
Yeah, that sounds good to me. Hopefully we'll get the girls here.
Sweet. Sounds good. Well,
Well, I
see
know
you
Neil
on
L.
Thursday.
Anderson is going to be here at for Devo in Rexburg, so I know Claire's not here, but Emily is. So her
Today?
yeah, Devo.
Wasn't it in 2 hours?
Yeah, but it's Neil L. Anderson, so they probably wanted to get there early, but still left us to dry. How could they?
All right, well, I'll see you guys Thursday then.
All right,
Awesome.
sounds
Take care,
good.
Austin. See you, Brennan.
Bye.